Section 1.7, Inequalities. A linear inequality in one variable looks like this. ax plus b is greater than 0. We could have a greater than symbol, greater than or equal to, that's where we have the line underneath it, a less than or a less than or equal to symbol. We're going to introduce interval notation in this concept. So first of all, we have what's called open intervals. These intervals are intervals that don't include your endpoints. So for example, if I wanted to talk about every number that's greater than 5, my set notation would look like this, x such that x is bigger than 5. My interval notation would look like this, 5 to infinity. The parenthesis is telling us not to include our 5. You'll notice if you look down here for the other intervals, we have some brackets going on. That means that we would include that endpoint. So for example, if we were talking about x greater than or equal to 6, our interval notation for that set would be bracket 6 comma infinity. That's telling me I'm including the 6 because I have an or equal to sign and then going to infinity. You'll notice that we never have a bracket next to the infinity because you can't include that. Let's look at this example where we have 5 is less than x is less than or equal to 15. So pretty much x is any number bigger than 5 and then less than or equal to 15. So in set builder notation, we have our answer like this. But if we want to look at it in interval notation, we're going to write parentheses 5 comma 15 bracket. Again, we're using the parentheses because there is not an or equal to sign on this sign. But there is one for our other sign, so that's why the 15 gets the bracket. Notice the graph examples as well. So pretty much we're going to put our answers on number lines, and above your number, in this case A or B, you're either going to put a parenthesis or a bracket and then shade whichever way you need to. More types of intervals that we could have would be closed interval, and that's where we're including both of our endpoints, so both A and B. A disjoint interval, so we're saying everything that's less than A and everything that's greater than B. Or the interval that includes all real numbers, so the entire number line. Example 1. Solve negative 3x plus 5 is greater than negative 7. So we're going to start by solving this using our normal rules of solving equations, even though it's an inequality. So start by subtracting the 5 over. And then we're going to have to divide by the negative 3 because it's attached to the x by multiplication. Now here's a little bit of a different rule. Whenever we divide by a negative, remember we have to flip our sign. So when we divide by negative 3, our sign is going to flip and we're going to have x is less than 4. Okay, and I'm going to show your answers here in 3 different ways. First of all, we're going to graph this solution. So a number line, I have 4 in the middle, a couple other numbers, 0 and 10 on there. And I used a parenthesis where 4 is because our inequality doesn't have an or equal to sign. And it's going to the left because I'm saying x is less than 4, just like 0 is less than 4. Another way is we're going to use interval notation to express our answer. So we have negative infinity up to 4. Again, we have a parenthesis because we do not have an or equal to sign. And the last way is set notation. So x such that x is less than 4. Solve the inequality. Give the solution set in interval notation. All right, I'm going to start by adding the 3x over, combining with like terms. And then I'm going to subtract the 7, so we're working to get x alone, and divide by 5. So I get negative 3/5 is less than or equal to x, or I can rewrite that as x is greater than or equal to negative 3/5. So now I'm going to graph the solution as well as write it in interval notation. Sometimes graphing helps us write it in interval notation. So since I have greater than or equal to, I'm going to have to use a bracket here because we have the or equal to sign underneath. So bracket, and we have x is greater than negative 3/5, so I'm going to shade everything to the right. So my interval notation is bracket negative 3/5 comma infinity. Example 3, finding the break-even point. If the revenue and cost of a certain product are given by these two equations, where x is the number of units produced and sold, at what production level does R at least equal C? Okay, so we're going to be comparing R and C. We want R to be at least equal to C. So R could be bigger than C, but we don't want it to be any smaller than C. So we want our sign to go this way. And I'm putting an or equal to on here because R could be equal to C. So now we're just going to plug in the two equations that we were given for R and C. And solving this, if we subtract that 2x over and then divide by 2, we get x is greater than or equal to 500. This means that our break-even point is at x equals 500. So this product will at least break even if the number of units sold is 500 or more. Example 4 is a three-part inequality. So normally whenever we solve an equation or an inequality, we have two parts. Whatever you do to the left side, you have to do to the right side as well. Well, this time, think of it as like three columns. So whatever we do to the middle to get x alone, we have to do to the sides. So in this case, I'm going to start by subtracting 5 from all three parts. And then we're going to divide by 3 on all three parts. So we get negative 7/3 is less than x, which is less than 5. So pretty much x is between these two numbers. So let's go ahead and graph. And now I'm going to use parentheses here because I don't have any or equal to signs on my inequalities. And then we can also write this in interval notation.